Hello. I'm Bretton, one of our MCAT tutors here at Inspira Advantage, where we help students get accepted into medical school and other professional programs. And welcome back to MCAT Bites. Today we're diving into structure and functions of the endocrine system. This system works alongside the nervous system to coordinate body functions, but it does so through hormones rather than electrical impulses. The endocrine system consists of glands that secrete hormones directly into the bloodstream. These hormones then travel throughout the body to target specific cells or organs. Let's start by looking at the major endocrine glands. We've got the hypothalamus, which links the nervous system and endocrine systems, pituitary, often called the master gland, the thyroid and parathyroid glands, which regulate metabolism and calcium levels, adrenal glands, which produce stress hormones, the pancreas helps control blood sugar, gonads produce sex hormones, and those are the major ones you need to know. Hormones are chemical messengers that can be classified into three main groups: peptide hormones like insulin, steroid hormones like cortisol, and amino acid derivatives like thyroid hormone. And then the awesome bucket of biology, miscellaneous. The type of hormone affects how it interacts with its target cell. Peptide and amino acid derived hormones typically bind to cell surface receptors, whereas steroid hormones can pass through the cell membrane to bind to intracellular receptors. So the question is why? Why can steroid hormones pass through membranes but peptide hormones can't? Well, this comes back to sort of organic chemistry. Like dissolves like. Steroid hormones are lipid soluble, allowing them to diffuse through the phospholipid bilayer of cell membranes, where peptide hormones are water soluble and thus cannot pass through the hydrophobic interior of the membrane. Now let's explore some key endocrine axes, beginning with, I think, the most important for the MCAT, the hypothalamic pituitary adrenal, or HPA axis. This is regulating stress responses, and let's explore it through CRH. So the hypothalamus would release CRH. This is going to go act on the pituitary, tell it to release ACTH. This will then go to adrenal glands to release cortisol. We also have the HPT axis, which is regulating metabolism. So the hypothalamus is going to release TRH, which is going to cause TSH to be released from the pituitary. And then the thyroid will release T4 and T3. When we have a lot of T4 and T3, metabolism is up. And in extreme conditions where it's too much, you become hyperthyroidic. You are really warm and pretty skinny. The opposite of that is you're not secreting enough T4 and T3. You get hypothyroidism. This causes people to be fat and tired. Then we've got the HPG, or hypothalamic pituitary gonadal axis. This is regulating reproduction. So the hypothalamus is releasing GnRH, which causes the pituitary to release FSH and LH. Then the gonads release various sex hormones, testosterone in the boys, and estrogen and progesterone in the women. The endocrine system is regulated through feedback loops, typically negative feedback loops. For example, when cortisol levels rise, it inhibits the release of CRH and ACTH, further reducing cortisol production. This is good. We don't want runaway production. That is not very homeostasis of us. Some specific functions of the endocrine system are regulating metabolism, regulating growth and development, reproduction, homeostasis, and stress responses. So what would happen if we failed to produce insulin in the pancreas? Lots of bad things. This is type 1 diabetes, characterized by high blood sugar levels due to the inability to move glucose from the bloodstream into many cells. The endocrine and nervous systems often do work together. For instance, the fight or flight response involves both the sympathetic nervous system and the adrenal glands releasing epinephrine. To wrap up, let's review a few key points here. The endocrine system consists of glands that secrete hormones. Hormones can be peptides, steroids, or amino acid derivatives. Major endocrine axes involve the hypothalamus and pituitary. The system is regulated by feedback loops. Endocrine functions include metabolism, growth, reproduction, and homeostasis. And the endocrine system often works in concert with the nervous system. Understanding the endocrine system is crucial for many areas of medicine, including endocrinology, reproductive health, and metabolic disorders, as well as getting you a lot of points on the biochem sections. Thank you so much for watching our video on the structure and functions of endocrine systems, and I will see you in the next one.